So in our first episode, we are going to talk about localization.
Explain to me the W. What is the W coordinate? I understand X, Y, Z. What is W?
So in the car, if you're on the highway, you want to make sure that you take the right turn, and that's the same with mobile robots. So you want to make sure that they drive, they reliably reach their destination, so they take the right path at the right time. And you need to know where you are to make that decision as a robot.
Welcome to the Mobile Robot Directory podcast, your guide to the world of autonomous mobile robots and automated guided vehicles. Join us as we explore the latest in mobile robotics, with industry experts offering insights and tips for enthusiasts, professionals, and newcomers alike.
Yeah, welcome ladies and gentlemen to the first episode ever of the Mobile Robot Podcast. My name is Emil Jensen and my co-host here is Javier Miguélez. Welcome, Javier.
Hello, good morning, and Happy New Year.
Happy New Year.
Emil, it's a pleasure to be here. It's a pleasure to be here in the first ever Mobile Robot podcast. My pleasure to accompany you today.
It's fantastic, Javier. We the two of us has known each other for I think several years now. We never actually met face to face. I think that's part of the story.
True.
But we known each other. We work together, and now we have a chance to start this the Mobile Robot Directory together. And this is our first podcast. So I think this is really exciting time for me. We also have a very, very exciting guest speaker today. So I want to welcome Vincent Burg from Accerion. Welcome, Vincent.
Thank you. Thanks for being on this on this podcast. And congratulations on the first episode, of course.
Thanks.
So Javier, what are we talking about today in our first episode?
So in our first episode, we are going to talk about localization, and it's I think the basis of mobile robotics today, and I think the most important way to start this podcast would be with the definition of localization. So what is localization? And at least from my side, when we are talking about localization, we are talking about knowing where we are. And where means usually four coordinates: X, Y, Z, and W. Most of the cases we can only use the three first ones, so X, Y, and Z. But in some cases we need the W, and the W is the turning. This is quite common. For example,
explain to me the W. What is the W coordinate? I understand X, Y, Z. What is W?
The W is the so what direction or what sense I am facing. For example, it's not the same being X, Y, Z, but looking at north than looking at east or west. So that is the turning, the way I am looking at. So the way I am heading. And the W is quite important, for example, for forklift mobile robots, because the way you place the pallet can be turn more to the north or more to the east. So it's an important coordinate as well. Some people forget it, but remember that in most of the cases in mobile robotics we have four coordinates: X, Y, Z, and W.
All right, so why is localization an important thing to understand when you are buying mobile robots? How does it impact the capabilities of the robot and so on?
So I always make an analogy with cars. So when you're driving a car, you need to know where you are because you want to go somewhere. And if you want to go somewhere, you start from where you are, right? So you need to define a route. And the route starts at the beginning and it ends at the end, obviously. So you need the coordinates for the start point and for the destination point. So that's why it is important. You need to know where you are, so that you can face the route ahead.
Yeah, I think that's a really good analogy.
Yeah, so in the car, if you're on the highway, you want to make sure that you take the right turn, and that's the same with mobile robots. So you want to make sure that they drive, they reliably reach their destination, so they take the right path at the right time. And you need to know where you are to make that decision as a robot.
Yeah, there's another analogy much used, which is that we are talking about localization for cars, but we are talking for guidance about guidance for rails, for railways, so for trains. And these are two different concepts. On one side, you have localization. This means that you always know where you are, and on the other hand, on the other side, you have guidance. And this is, for example, the case of trains is very interesting. Why? Because you're going from point A to point B, but you don't know where you are in between point A and point B, and you don't care because you are just following the rails. So that's what makes a difference. In the case of localization, you always know where you are. You always know your coordinates. In the case of guidance, you only know the start and the destination. You don't know where you are in between, and it's not important. It's not really important. So if you're going from Paris to Berlin with a train, you don't care where you are in between. So the only important thing is that to know the start and to know the destination. On the other hand, when you're going to localization, it's important where you are all the time. For example, it would be impossible in Paris or in Berlin or in London to go from the origin to the destination with only guidance. You would need a localization with a car for sure.
So let me see if I understand this correctly, Javier. The guidance is a similar concept like a train on a track. You know that you are between two stations, but you don't really care exactly where you are on the track. And the localization, we can think about it as the GPS signal for a car that tells us exactly the coordinates of where we are. For GPS, it's a global positioning system. And I guess for mobile robot, it's positioning system within the defined space that the robot is in. Is that correct?
That is correct. In fact, GPS is a localization technology.
Okay, so let's go through a little bit. What are the guidance technologies? Where did we come from with AGVs and so on? And what are the new technologies that are being used today?
I think actually, so you mentioned rails, and I think the first AGV, if I recall correctly, was rail operated. I'm a little too young to remember it myself, but it was in 1953, I think. A company called Barrett, they made the Guide-O-Matic, I think they called it. That was actually on rails, I think for paper industry or something like that.
Yeah, that was the first mobile robot ever, in fact. Yeah, and it was rail guided. Yeah, the first mobile robots in history were rail guided or mechanically guided. Maybe it was not a rail like we are thinking about a train. It was a different kind of mechanical guidance, but the first mobile robots were mechanically guided. Apart from this mechanical guidance, we have mainly three others, which are wire guidance, magnetic guidance, and optic guidance. From these three, let's say that wire guidance, you cannot see it anymore in new deployments. In old ones, you can find some still. Optic guidance is not that common, but in clean rooms and very particular industries, for example, in aerospace, and magnetic guidance is still really common in automotive industry. Maybe you can discuss later why. So for sure there are guidance applications today, but they are less and less common because the flexibility that you have with localization is much greater. So today most of the mobile robots deployed are using localization technologies, no longer guidance technologies.
So I was going to ask, so code tape, would you also consider that as guidance or more as localization? Maybe splitting hairs, but
can you repeat that? Sorry.
So you have this tape that basically has QR codes on it. Would you consider that as guidance or localization?
That is a localization, in fact, because you are localized all the time. You know where you are all the time. So that's a localization. You mean the QR code strip, right? The QR code tape, but you're always localized. You're always localized.
Yeah, so I was just thinking, what are the new things that are enabled by going from simple guidance to localization with the X, Y, Z, B, W coordinates? What capabilities do we get with these new technologies?
So I think that the most important capability that we are getting here is the flexibility. So you are So if you're working with a guidance, you need to change the guidance reference, when you need to add a route and when you need to modify the route. And with the good thing with the localization technologies, in many cases, is that you don't need to do that. You don't need to do that. This is the first thing. And the second thing, and I think that this is interesting as well, is that being always localized can help to know where the mobile robot really is. So, for example, in the case of the train that we were mentioning before, you don't care if you are in between, but in some cases you need to know if the train has had a problem, and you need to know where the train is. So localization helps problem solving for sure.
It helps find the robot. I could imagine that you can achieve pretty much the same thing as you have with the guidance and the magnetic lines and so on. You can achieve that also with SLAM localization, is it right? So you're switching to a more flexible technology, but you can still have your software guides, if you will, right?
That's it. That's it. There are, well, some people say that guidance is like easier from a programming perspective, which it is for sure. But the main disadvantage is that it is too fixed. It's not flexible at all. So when you need to make a change, you have to take out of the magnetic tape and place a new one, and that is cost and that is time for sure. And regarding the modifications with localization technologies, well, are much easier, let's say so. Not from the programming point of view, but most of the cases from a physical point of view.
And so also from a programming point of view, I would say, because it's not just about the time it takes to add more tape on the floor to go to a new position. It's also the fact that the robot, the old traditional guided robot, is kind of dumb, right? And in order to change the path and the lines, you have to actually reprogram it, because it's just go to this position, wait for 5 minutes, go to the next position, and so on. So with the localization and the map and everything being in software, I think you get the ability to deploy much quicker and also make changes much quicker than not just the time it takes to stick the tape and remove the tape, but really programming the robots become also a lot easier.
For a large amount of robots, that is correct. For small numbers, it is not. I'm saying this because, well, as you were explaining, Emil, when you have a guidance, you have a PLC architecture, so it's pretty simple, and almost everybody can program that. When you're going for localization, this means IT, and so many people, well, they are not that skilled in IT programming, and well, you need much more training. Um, so anyway, for a small number of mobile robots, maybe magnetic tape guidance is easier from a programming point of view. But when you go to, I don't know, 20 or 30 or 10, forget about it. It's going to be much easier to program a localized AGV than a guided AGV mobile robot.
Yeah, I was going to say this flexibility. I think it's becoming increasingly more important, both in manufacturing and in logistics. It's at least something that we've seen over the past years, that people are increasingly looking for solutions that can be easily expanded, changed, optimized over time. Yeah, and then you always involve some form of routing updates. So I think it's becoming increasingly important in the market.
Agree. Yeah, absolutely. Flexibility and modularity are key today. So actually, you don't know what your needs will be tomorrow. So you need to be able to modify anything in a really fast and easy way. So flexibility and modularity are key for mobile robotics. That's for sure.
Yeah, I think it's also a bit of the traditional way is using conveyor belts and all kinds of infrastructure that was very fixed. Yeah, and it's the promise for mobile robots is to get away from that and become much more flexible and scalable over time, up and down. Yeah, and I think this really shows and fulfills the needs.
Yeah, in fact, one of the main advantages of mobile robotics or mobile robots in general is that you can move them. from one facility to the other very easily. Go with a conveyor to move them. It's going to be crazy, right? So the flexibility again is a key feature of mobile robotics. So if you're able to increase the flexibility of your mobile robot by using localization, better for the customer. That's true. That's why actually we have seen a boom in localization technologies for the last 10 years. That's the reality. You know much about that, Vincent, I'm sure.
Yeah, Vincent, I was going to ask you within this category of technologies that we call localization, there's a lot of flavors, and maybe you can tell us a little bit about what are all the different ones that we can encounter.
So I think there's like you said, there's quite a list. So besides the guidance technologies, of course, but if you look at the localization technologies, I think there's three main categories. So one is using some infrastructure in the environment, usually with reflectors and a Lidar scanner, or magnetic transponders in the floor. And there's a second category, I think, is the QR codes, the QR tags on the floor or data matrix, which basically when robots drive from tag to tag, mostly used in e-commerce and larger sortation and goods to person applications. And finally, there's the real, I call them free navigating solutions, like that are mostly based on the SLAM, or that use some form of natural features in the environment. And basically, they use all the sensing and technology that's on the robot to localize themselves within an environment. With the most important point there is that the environment doesn't need to be changed for the operation, or at least mostly not. Yeah, and then I think what we've seen the last, especially 5 years, the Lidar SLAM has become the de facto, I think, market leader or market leading technology there that's now being used today.
So Lidar SLAM, you say, is the market leader and the new de facto. So does that mean that's all I need to care about, and I should use Lidar SLAM for everything, or is there justification that we have all these different technologies? Are there something that they each are better at, or how should I go ahead and decide on technologies as a buyer and a customer? What should I be looking for?
Okay, I'm going to answer that one. Sorry, Vincent, this is for me. I'm going to keep it. Any technology that we have mentioned here has limits. And 2D SLAM, 2D Lidar SLAM, or Lidar SLAM, or any other SLAM, or any other technology has limits. Particularly, the problem with the 2D Lidar SLAM is the environment. So the 2D Lidar SLAM actually is the one that we can have at home with this Roomba and all these cleaning robots. So it's a common technology and much used. The main problem comes when you don't have references. And just taking the Roomba example, if you don't have walls at home, this is not going to work. This is not going to work. And if you have so many people around the mobile robot working, it's not going to work. And if you have a changing environment, so for example, that you have walls, but these walls are changing every day, it's not going to work. It's not going to work. Particularly, you can find all those requirements in automotive industry. So if you go to automotive industry, you will see that there are no walls, people are working around, and the few references that can be fixed may change every day. So that's one of the reasons why it's very difficult to see SLAM technologies working in automotive industry and why they are using magnetic tape today. So it's not like SLAM technologies are good for any kind of application. That is not correct, and it's important to take that into account. And actually, one of the reasons why the Accerion technology that I think Vincent will have to explain it is a really interesting technology, is because it can work. It is a localization which is not using the environment, and that makes a difference, definitely. Vincent, I guess that you can explain more about the Accerion technology and how it works.
Yeah, of course. So so we build a technology that localizes using natural features. So like any SLAM technology, but instead of using the natural features in anything that goes around the robot, so things that change often, we use the natural features of the floor to navigate. So we built a technology that is able to recognize where it is, to define its location based on basically looking at pictures of the floor. And to do that, of course, it takes a lot of software, and we've built it into a product that we call Triton that can be added to mobile robots, to existing mobile robots, or to new standalone or integrated in a stack. And yeah, you're right. With it, since we look down at the floor, we overcome some of the limitations that the other natural feature-based solutions have. Since everything can move, everything can be wide open areas, ramps, dark lights. For us, it doesn't matter as long as we can see the floor. We can localize.
Okay, so hold on a second, Vincent. Let me understand this, because the 2D Lidar SLAM, I can kind of understand that the robot is looking around and it's seeing all the things in its environment, and that's also how I get around, right? I look around, I see what is there, and then I know where I am. But you're saying you're looking at the floor, and I cannot find my way around by looking at the floor. So there is something going on here. What exactly are you looking at, and how does that work?
Yeah, so if you look at the floor, I don't know what, probably in the floor of your office as well. If you look at the floor, you will see, like a microstructure in that floor. So it's I always compare it a little bit to your fingerprint. So there's you can recognize these, say, unique fingerprints in the floor if you have our software, of course. Since we can analyze pictures while driving, and based on what we see, we can link that to one of these fingerprints that we already have in the database on the device. And once we recognize it, we give out the position. So that means that the floor is so, at the way we look at it. Of course, it took some development to get that right, quite some development. But the way we look at it, the floor is unique enough locally to use it for localization.
So let me make sure I understand this. You have floor fingerprints, which, if I understand correctly, it's a specific piece of the floor that has a unique fingerprint, and then you can drive from fingerprint to fingerprint, which reminds me of the QR codes, right? So it's kind of the thing that you have, you're driving from picture to picture, and you know what picture you are on top of, and that's how you can localize. But you don't have to deal with sticking all the codes and maintaining all the codes and all the hassle that comes with QR codes. Is that how I should understand it?
Yes, that's essentially what it is. And then
it has an advantage, I have to say. So apart from what Vincent has mentioned, that was a surprise for me, 6 months ago or 12 months ago, is that they are updating every day the pictures that they are taking from the floor. So it's like updating every day the fingerprint. So this means that no matter if your floor changes, they update it. So this is a problem that you can face. So you were mentioning, Emil, this is a problem that you can face with QR codes, that they are damaged after time. They are damaged. In their case, they are updating the picture of the floor every day. So this means that you are not facing that problem at all.
Okay, so this is it sounds very robust to me. It sounds like you get around the issues of no walls and all the chaos that is happening in the automotive plant, but you also get around the weaknesses of QR codes and the maintenance of that. You have a software solution, basically. What about free navigation and behaving like an AMR? Does this technology work if I want to do obstacle avoidance and not stay on a specific path?
Yeah, absolutely, and it all depends on how you build the map. So in the simplest way, we simply follow a line of fingerprints. That's a line guidance. It's like a guidance technology. We actually have one of our customers who's very successful with that. But in most cases, we want to build like a grid map, which means that we have a grid of lines, usually 1 or 2 meters apart, that essentially becomes the invisible navigation grid. So then every time you cross one of these lines, you get localization updates. As long as you can drive in that operation every meter or every 2 meters, you get your millimeter level accuracy localization updates, and you can use that for navigation. Now, what we don't do, of course, we don't look forward. We look down, so we don't look forward. So if there is an obstacle, you need your safety system, your safety lidar to give that data back. But what we can do is once you in your navigation system know, oh, that's a place where there's a new obstacle, we can still we can support driving around it.
My question would be, so we were saying before, or I was saying before actually, that all technology has a limit or has limits. Where are the limits of Accerion technology, Vincent?
Yeah, so we use since we use the floor micro texture to navigate. We need a textured floor. And that means so we built it originally for concrete. So basically all concretes work. But then on the other extreme of the spectrum, there are they're very brand new white epoxy floors. Or for instance, in China, there's a green type of epoxy that is just very shiny and very featureless. Yeah, that's where it doesn't work. So we have to have we need texture on the floor to navigate. But yeah, we see in practice we can predict it very good, and it's a simple test with a Triton if there's doubt. And we've got procedures in place to make sure that we can support the operations.
What about outdoor?
Yeah, outdoor interesting. So there's outdoor. It will work outdoor. But since outdoor we don't have the elements under control. If there's a snowstorm, if there's sand on the floor, if there's mud rain, there's basically the rate of change is so high that our algorithms can't simply pick it up. So that's why we choose to stay indoors. There's plenty of work indoors in our industry, as you will as you will agree. But who knows? Maybe I think it's an interesting space where a lot of interesting things are happening, and one of the interesting places where our industry will go to in the coming years. So who knows? But at the moment, officially, it's not supported.
Not supported. We have talked a lot about indoor localization, but outdoor localization is pretty interesting as well. Using the SLAM technologies, for example, for outdoor, is quite risky, let's say so, because you can be affected by rain. So just using the Roomba example that we were mentioning before, with Roomba, when you're at home, the Roomba can see the walls around, and the same happens outdoor. But when it starts raining, maybe you don't see the walls anymore, and that happens. So in my experience, using SLAM localization for outdoor, is difficult. It's difficult and risky. So that's why other technologies such as GPS, RTK, or the differential GPS are widely they're widely used. Nevertheless, there are limits to those technologies as well, and I can say that there is no clear solution for an outdoor localization today. So though most of the people go for RTK, or RTK GPS, you can find really many problems with that. So it's not a solution that can work 100% or even 90% of the time. I don't know, Emil, if we have still time to go or to dive a little bit into the problems that we are facing outdoors.
Yeah, definitely. I mean, I also want to get back to Vincent, and I want to hear about how you came up with this idea. It's quite unique, but let's round up on the localization, right? Because the question then is, who is the winner, and what do I choose as a user, right? So if I can try a little bit to think about this, I would say that outdoor, Javier, you're talking about there is no clear choice right now. There are multiple different technologies. Maybe you can explain more about how to choose between them. And then indoor, it seems to me that it's a trade-off between the flexibility of localization system versus the robustness of traditional, magnetic tape just works, and you don't have to care about what is changing around you and so on. And then you have new technologies like what do we call your technology, by the way, Vincent? What's the name of it?
Yeah, we call it texture vision.
Texture vision, right? So this to me seems like it has a really good mixture of not being dependent on seeing the world around you and recognizing things in the world, because that can be challenging, but also not being, infrastructure based. You don't have to change your environment and so on. And then the limitations, as I got them for the texture vision technology, is that on certain very shiny floors, it can have some challenges. But is it fair to say that it works on most industrial floors, or do you have like a percentage, or how should we think about it?
Yeah, that's tough, of course, because it's kind of an open question, like how many floors exist. But we see in most common industrial applications, it's not a problem. And yeah, there's so concrete always, any textured floors, and if there's any doubt, then we have a quick way to measure it, and then we find that in practice that's sufficient. And it's and for us it's going to be the we of course ultimately we want to support every single floor, but that's going to be a longer term project.
Have you anything you can add on what do we need to think about as when we go out and select the robots, right? I want to buy robots for my project. What are the key things I need to think about in terms of localization or guidance?
So I would say that if you go for indoor applications, you have today mainly 4 options, divided into 2. The first one, which is the SLAM, widely used, as long as the environment doesn't change, I insist. And then if your environment is changing, you can use QR codes, you can use magnetic tape, or you can use Accerion technology. The good thing is that Accerion technology can work on any. So most probably Accerion technology will end up replacing the QR codes and the magnetic tape. That's my point of view. So in the future, we'll have only SLAM and Accerion technology. If you go for outdoor, the discussion there is much broader. But either you go for RTK or you go for magnetic tape, or you have really few options. So these 2, I would say. This is what we have in the market right now. So I repeat again, for indoor, you can go for a SLAM in case that you have a non-changing environment, or you can go for QR codes, magnetic tape, or Accerion if your environment is changing. And if you go for outdoor, then magnetic tape or RTK. This is generally speaking the landscape of technologies that are being used today.
All right, thanks, Javier. That's actually super helpful. So my final question before we wrap up is for you, Vincent. This is just a super fascinating technology. I don't think I could have come up with the idea of fingerprinting the microstructures in the floor. Tell us a little bit about the story behind this technology and the company itself.
Yes, it actually started with a research project in automotive. There was a need for to measure the pose, so the X, Y, and the W, Javier, for you, on the road.
And X, Y, Z, and W. So there are 4.
Yeah, in this case, yeah. So no, it's 3 out of the 4. So X, Y, and heading. That was the key thing to measure. And this was done actually by the original founder of the technology. So he needed a way to measure that the pose of the car during corners. And he basically took apart an optical mouse and tried to figure out if he could use that data for it. Well, it seemed to work. And then he got the idea, like, could we apply this also in robots in some way? And that's around the time that that I also joined us, about 8 years ago. Initially, we started looking at a robot to feed cows. It's a pretty big market. Basically, it's bringing the cow feed to the cow so that the farmer doesn't have to do it. But we quickly found that it was quite a difficult market to enter. And then we basically pivoted to a market that seemed to be growing very fast, and still is actually. And that's the intralogistics market, and focusing not on building a robot, but on the technology, which we found was actually the core asset at the time. And that turned out to be quite a good approach. And initially, we actually only found the core of the technology a little bit later, because we had this optical mouse technology which just tracks, so you can put it anywhere and then it tracks its distance. And we needed a way to calibrate that tracking. And then we found that, of course, through many trials and errors, that we could actually not only track, but we could also measure the exact position. And initially, this was only the idea to use this only for calibration of the signal. And then later, that turned out to become the core of our product. And of course, so this is over 8 years. We made many iterations around what exactly is what we want to bring to the market, what exactly the key challenges are today, and this turns out to be what's our core focus now. So that's a little bit of the backstory of how we came here, from cars to cow feeding to localization and intralogistics.
Yeah, that's quite a pivot.
Yeah, exactly. Yeah.
Well, I am a believer of your technology, Vincent. Really, I think for indoor, it's a game changer. Really, it's a great technology.
And as we see, you mentioned SLAM now. I think the 2D SLAM that will stay for quite a long while, especially since it's pretty much the only technology that can support safe operation. And so in addition, what we now actually see quite a few projects where we basically support SLAM systems to operate even in complex environments. So I think we're on a good track. So I hope we'll make a real impact in the market with what we do.
So Vincent, if our listeners want to learn more about Accerion, where can they find you?
Of course, in the major trade shows, Logimet is coming up. That's will be in the hall with all the AGV manufacturers, but also simply online on Accerion.tech. That's our website. And then I'm always happy to get in touch and learn about new projects or solutions that we can maybe support.
Wonderful. And a big thank you, Vincent, for being the first guest on our Mobile Robot podcast. And a thank you to Javier. And thank you to all the listeners for tuning in. And this is a wrap of the first episode of the Mobile Robot podcast.
Yeah, thanks. Thank you too. It's been a real honor to be here as the first guest. Much appreciated.
You have been listening to the Mobile Robot Directory podcast. Each month on the podcast, our two host and co-founders, Emil Jensen and Javier Miguélez, talk to industry experts and take a deep dive into a specific subtopic within mobile robotics. If you haven't already, do check out the Mobile Robot Directory at www.mobile-robots.com. Thank you so much for tuning in. See you in the next episode.